Well, John, everything's looking great. We're just going to run your routine blood test now.
What?
Hi, John. Your test results have come back. It looks like you're in good health.
Alright, thanks, Doc.
Alright, we'll see you at next year's physical.
Alright, thanks, yeah.
John, I'm really sorry to tell you this. You have stage 4 lung cancer. You found this out a bit too late. You have 3 months to live.
But wait a moment. This story doesn't need to end so tragically. That's because we at UBC BIOMOD have the solution. Lung cancer can be correctly identified by a set of biomarkers called microRNAs. MicroRNAs are small strands of RNA that are present in your blood. Their concentrations begin varying noticeably and quickly when cancerous cells appear. UBC BIOMOD has designed and developed a modular assay for a microRNA specific to lung cancer in order to detect these variations in microRNA concentrations. Our method is simple, cost-effective, and easy to use in any lab. This provides the patient with early diagnosis, which can increase their 5-year survival rate from 2% to 31%. We start off with a loop of 100 nucleotides folded into a dog bone structure. Each dog bone structure has a domain complementary to the specific microRNA. Part of the domain is in the single-stranded loop portion, while the other part makes up the stem. When the microRNA with matching complementary bases approaches the dog bone structure, it will first bind to the loop portion of the DNA and then zip open the stem while attaching to the rest of the domain. The DNA polymerase joins next. It will bind to the microRNA DNA complex site. Its job is to amplify the signal by rolling and replicating the DNA 10,000 times. Now that we have a large amount of DNA, we will use a carefully chosen restriction enzyme to cut it into pieces. This allows the DNA to be mixed all over the liquid instead of gathering at one point, which makes our data much more reliable. Finally, we add a DNA stain. This stain produces a fluorescent signal that would depend on the amount of DNA, which itself depends on the amount of microRNA. From these signals, we can find the concentrations of microRNA. Based on these concentrations, we can efficiently diagnose lung cancer while the patient's chances of survival are still high.
What?
Hi, John. I need to see you soon. Well, John, I have good news and bad news. We've detected cancer in your lungs, but it's treatable because we caught it so early.